Okay, hey everyone. We're going to dive into instancing. And I think I'm going to do maybe three different parts. There's kind of fundamentals and then some other tricks, other techniques that we can use. It's a very flexible thing, very, very useful. Let's just dive into part one here so we can see some like Fruit Loops floating in space, something like that. So what we have is a single geometry that goes into a geo, and then that geometry gets instanced into lots of copies. And so properties like if we could look at the instance tab on the geometry, properties such as the translate, the rotate, the scale, things like pivot, other this like rotate to rotate up. So these I've never really played with too much, but other parameters we could play with. Texture mode, if we're on a PC, we can instance textures, so that could be the content of a further demo. I'm also playing with the color here, so assigning. So this is actually different from a material. We can actually assign individual instances a certain RGB color. Great. So all that stuff. In this example, we are controlling with these chops. And let's just start our own little thing here. Let me maybe just start. You know what? I'm gonna copy these, and I'll make a new container. And let's just dive into that one. We still got our backup there as needed. Okay. All right, so now this is giving me an error because I've got instancing turned on, but then nothing is actually there. Actually, let me just get rid of these for now. We can build that in a moment. And color, get rid of that. Okay, so we've got a lonely torus right now. To get started, let's just I can do like a simple noise and just kind of have it be one thing. So we learned previously, if we go into channel names here, I can do a little trick, like I can write multiple channels within that. I could do things like 1 through 8. That just made 8 channels of noise if I put it in brackets here. I can also do something like T and then in brackets X, Y, Z. So a few different ways we can do that. And by default, middle click here. So by default, a noise has 600 samples. And I can control that right here. So I'm going to, maybe to start, I'm going to keep that a little bit lower. I'm going to do maybe like 20 total. So 0 to 19. And how should we do this? We can like play around with period maybe. So whatever, that's fine. Let's just see what happens with that. So with just this one noise, let's go into, so instance, usually by default this is off, so we have to turn that on. And I'm going to use this noise as my translate operator. So bring that there. And then the X, Y, and Z is going to be used. It's going to be mapped onto the instances. I have to tell it which channels of this. And so in our little triangle menu that pops up, it kind of shows us what channels are there. So that's cool. All right. So that's, you know what? Maybe I'm going to use a little sphere to start with, just to show that a little bit better. Okay, that's like a huge glob. Let's bring radius way down. Okay. So we get a sense of what's happening already. So my amplitude of my noise is just the default amplitude 1. So it's really going, I mean, I can look at these values like roughly, you know, 0.5, negative 0.5. So that's being translated to the TXT, YTZ properties of my instances. And they're all kind of like bunched together in the middle. So what I can do, I can play with the amplitude. So that kind of blows them apart a little bit, right? So now I've got these values that are a little bit higher, a little bit more spread out. And I've got 20 samples here. So I have 20 spheres. So pause it and actually count it if you want to, but trust me, there should be 20 there. And then we can do things like, you know, standard abs time dot seconds. On the transform, let's do. Oh wait, it's not doing anything. It had hit space bar, so it was like not moving. Okay. Oh, that's cool. That's like a little thermodynamic experiment with little molecules. That's pretty cool. Okay. So, generally speaking, that's it, right? That's what instancing is. But to create a nice system, we get into things like I'll just keep it at 20 channels, 20 samples for now, maybe. Let me go ahead. I'm gonna call this translate. So I'm gonna start building kind of similar thing where I've got a null. I'm gonna name that translate just in case I wanted to, add some other thing in the middle there. So now what I'm gonna do, maybe I'll get the torus back, and that's fine for now. I'll add a scale later. Let's add some rotate maybe, because the toruses are all kind of flat. So I can do another. You can do it however you want, like noise, any other kind of thing you want to come in here. I want to get values for rotate XYZ. So we're going to create a new noise, and then we'll do the same channel. I'll do this R XYZ. So I've just created those right there. And okay, so for rotation, really we're thinking from 0 to 360 degrees is what we want, right? I'm going to go ahead and let's just see what happens there. So that's going to give me some different values. And okay, so then I have to go in. This had how many? 20 samples. I'm going to go ahead and just plug this in, and we'll see an error because the sample lengths are different. But let's see what happens. Let me go back in here. Let me tell that translate now. So for rotate, let's do this. Let's grab these values. Okay, great. So what does this say? All ops must generate the same number of instances, have the same length, right? So these are different sample lengths. Therefore, the geo doesn't know, okay, how many instances am I actually supposed to create here? So they have to start with the same sample length. So I could go in here and I could manually change this. So it was at 0 to 19, right? Okay, so that worked. That looks pretty cool. But I'm envisioning a future where, what if I had like chop situations for like scale, rotate, translate, color, like lots of information. I have 20 instances right now. What if I want to play around with, let's do 50, let's do 80, let's do 200. If I have to manually go in here and change that in each of those, that's going to be a big pain, right? So right off the bat, what I'm going to do is I'm just going to use a constant and whatever. Oops. You can name it whatever you want. You don't even need a special name, but instances. I'm going to go ahead and say 20. And I'm going to use this as a kind of master controller for that. So from here, instead of typing that manually, I'm going to do a little reference. And let's do actually -1. Okay. Same thing here. -1. Okay, great. So now in one place, I could change this number. Let's try 50. Let's try 5. Cool. Okay. So that's looking pretty cool. Let's keep it at 20 for now. I'm okay with that. And actually, let me spread these out a little bit more. Okay. Okay, so I think rotate looks okay. Let's do, what did I do before? I did like color. I'm just gonna add a bunch of like noises here just to kind of be quick, and I'll do a little just random. So if I'm working towards color, let's do RGB. Point color is expecting a range of values from 0 to 1. And this is -1 to 1, so I'll just do an offset 0.5 and the amplitude 0.5. So now this gives me roughly from 0 to 1. Okay, great. And I'll do the same thing. And let's do this here. Actually, this is going to, just wait a second, this is going to be a problem. So, okay, this says that, do -1, great. But I didn't change this. So this is still at seconds. So this is actually giving me a lot of samples. So we need to change this to samples. Now that's better. Okay, call the color. And the colors on the next tab here. Grab R, G, and B. Okay, beautiful. I've got these colorful Fruit Loops. Okay, great. And one thing to also keep in mind, so this, I mean, this is generated totally random. Actually, let me try a constant. Let's see what happens. Random colors. You could really fine tune this right here. So let's say, like, okay, what if you want maybe the red to be stronger? You could do something like you can have separate noises, let's say, for each color channel, and then maybe the amplitude of the red channel is higher. For green and blue, it's like lower amplitudes. You could, do it all with one noise, and then maybe select, and then maybe let's select G and B, and then we do maybe like a math 0.5, and then merge these back. So, look at that. Actually, I did not want merge. You see what happened here? So I still the same like RGB is there. I mean, then when I merged, it created new G1 and B1 channels. So I was being stupid. Replace is what we want. So this is also a really handy chop. So replace will take this original, and then it's going to, if there's the same channel names, it's going to replace it with the new information. There we go. Okay, cool. So this is essentially, attenuating my G and B channels. So many different ways that we could do that. Another thing we could do, so actually let me just get it back to this normal one. Okay. We could add extra material. Yeah, that's kind of cool. And if I added a color here, so the material has this kind of lavender color, and then the geometry colors that I'm determining right here, it has a certain relationship to that. So you've got replace, multiply, add, subtract. So this does different things. Maybe I'll just keep it at replace. That's fine. Okay, not bad. So let's look a little bit closer at the rotate here to see some variations that we can do on that. I'm gonna make that animated. So here we can see, right, they're all kind of moving, but depending on what type of rotation that you want, maybe this isn't quite right. Because I was thinking before, it's kind of nice if it was like a continuous revolution that goes around 360 degrees, and if each of them was different. It's right now with the noise, it's not doing that. It kind of just, it has a kind of more randomized movement to it. So let's try something else. In this example, I used 3 LFOs and then a merge, and then the trail is getting this length I defined right here, and then I'm sorting that randomly, and then that. ends up being the rotate values. So that leads to something kind of like that. Okay, but let's do something different. Just to experiment with another type of operator, which is a pattern chop we haven't really looked at. So this is similar to an LFO in a sense, but it's like it's not really changing over time. It's kind of a set form. So let's just do ramp, and I need amplitude to be 360, and so I'm going to get a little crazy. I'm going to do, okay, so length 360. So if length is 360 and amplitude is 360, so I should have a value for each, like from 0 to 360 or something like that. There, let me actually do channel. Let's do R, X, Y, Z. And let's do a sort. Let's see what happens with that. Let's sort them randomly. Okay, so now XYZ has these sort of random numbers that are essentially going from 0 to 360. Okay, great. And then let's trim it, because right, I have way too many samples here. Let's trim it according to this right here. So I'm going to do an absolute, and I'll do -1. Okay. So this is trimming me down to 20 samples, as I should be. Okay. So now, what if I played with this phase? Okay. I like that. So let's do absolute time dot seconds. Okay, fine. And then this, of course, I mean, I could make 3 of these with different speeds that they're changing. Right now, the rotation on all 3 axes is going to be the same. So, you know, whatever. Actually, you know what? It is kind of nice if only one of them is fast and the other 2 are a little bit slow. Let's see what happens with that. I'll do RY. Z. So let's say, so RY, let's keep it that speed, and then these other 2, I'm going to make it a degree of magnitude slower. And then merge it. And then go in here. So just fine-tuning how all those things are playing with each other. Okay, great. And I'll just do a quick little random thing here for the scale. And again, let's say I want scale to be, you know, maybe at the smallest. Just like that. So it's going to go down to about 0.2 and up to 1. Or actually, let's do it different. Let's do a little bit higher, and then amplitude. No, that's fine. Same deal. I'll just call it scale for one. I'm not going to use separate dimensions for that. So scale XYZ is going to just be the same thing. So I'll just use 1. Okay. Okay, that's fine. And let's bring that in. And then for all 3 of these, we'll just use scale. Okay, cool. So, variation, right? So, very quickly, right, you can see how this could lead to pretty cool visual patterns and behaviors. Maybe line is not so good there. Let's try a Phong again. Now what if I made this So, okay, I kind of like that. And then what if we had some more? So the cool part also, with this translate, we could start to play around with, oh, that's kind of nice. Look at that. Right? So Brownian motion is kind of cool because it automatically, the start and end points have the same value. Let's look at this right here. So instead of a more randomized field, it kind of feels like more of a cool little loop pattern, like superstring theory or something. Another trick, so this is also kind of like a little extra, just more noise techniques, really. If we look at constraints. So normally for a noise, right, the beginning and the end do not meet at all. But we could do constraint, start end value. So look at this. So the beginning of all these is whatever value you give it, and also the end. So this creates almost like the Brownian noise where they kind of meet. It's still pretty noisy, pretty random in the middle of that, but it's kind of nice. I guess for this it doesn't really make as much sense, but maybe if I do something with a smoother thing there. Okay, I'm liking that. And then I think I need to boost up the amplitudes. Okay, so now we can see a little bit better. It's starting to look kind of like the Brownian thing. The cool thing about if you do with the sparse noise, you can still do a translate. For the Brownian, you cannot do that transform anymore because Brownian noise is calculated in a different way mathematically that doesn't allow itself to have that extra translate. Okay, so that's kind of cool. It's like a little jittery thing. Maybe let's bring this out some more. So then, of course, maybe a null to kind of frame it. Lots of possibilities. Okay, that's good for part one.